Artificial intelligence does not replace intelligence analysts, but it increasingly assists them. In modern counter-terror environments, the volume of data is too large for manual review alone. Communications, metadata, open-source material, financial signals, travel patterns, and digital interactions generate vast datasets. AI systems help structure that data. They do not decide guilt. They do not authorize action. They help identify patterns that require human assessment. So how is AI actually used in UK counter-terror intelligence analysis? First, it is important to define what AI means in this context. In intelligence environments, AI often refers to machine learning systems designed to detect anomalies, classify data, and prioritize signals. These systems do not understand ideology. They identify statistical irregularities. They compare current data to historical baselines. They highlight deviations. For example, an account that suddenly increases activity across multiple platforms. A cluster of devices showing coordinated behavioural shifts. Financial transfers that match known structural patterns. AI systems flag. Humans interpret. One major application is anomaly detection. Machine learning models are trained on large data sets of normal behaviour. They learn what typical communication patterns look like. When behaviour deviates significantly, the system generates alerts. This does not imply criminal intent. It indicates statistical irregularity. An analyst then evaluates context. Another use is classification and prioritization. Intelligence teams often process large volumes of open-source material. AI tools can assist by categorizing content, identifying extremist language patterns, ranking material by relevance. The system reduces the review burden, but analysts verify outputs. False positives remain possible. Human oversight is essential. AI is also used in network expansion modeling. After link analysis maps a network, machine learning systems can simulate growth scenarios. They may identify potential recruitment pathways, likely bridging nodes, structural weaknesses. These are probabilistic outputs. They inform strategic thinking. They do not dictate action. Natural language processing plays a role in multilingual environments. Extremist content may appear across languages and dialects. AI systems can assist in language detection, translation support, topic modeling, sentiment clustering. Again, the objective is signal prioritization, not automated prosecution. Another important domain is risk scoring assistance. Structured analytical frameworks evaluate factors such as intent indicators, capability signals, acceleration patterns. AI models can help aggregate these signals into risk-weighted dashboards. But the final judgment remains human. Thresholds for action are legal and procedural. They are not algorithmic triggers. Predictive modeling is sometimes misunderstood. AI does not predict individual future crimes with certainty. It can model network trajectories based on historical patterns. For example, networks that show rapid decentralization after central node removal, clusters that historically escalate after specific behavioral changes. These are trend comparisons. They support planning. They do not replace investigative judgment. Oversight and governance are critical. AI systems used in intelligence contexts must operate within legal frameworks. Data access requires authorization. Model use must be auditable. Outputs must be explainable to decision makers. Algorithmic transparency matters. Operational decisions cannot rely on opaque systems alone. Human accountability remains central. It is also important to understand limitations. Machine learning systems depend on training data. If historical data contains bias, models can reflect that bias. If behavioral patterns evolve, models require retraining. If adversaries adapt to detection methods, signals change. AI is adaptive. But so are networks. Technology evolves, so does risk. In practice, AI in UK counter-terror intelligence functions as an analytical accelerator. It helps surface anomalies faster, map relationships more efficiently, prioritize investigative focus, integrate multi-source datasets. But every flagged pattern still enters a structured assessment process. Intent must be evaluated, capability must be verified, Legal thresholds must be met. Operational decisions require proportionality and authorisation. AI assists analysis. It does not authorise action. Modern counter-terror systems are layered. Data collection, network mapping, risk modelling, human assessment, legal oversight, operational response. AI strengthens the early analytical layers, but the decision architecture remains human. So how is AI used in UK counter-terror intelligence analysis? As a tool for anomaly detection, as a classifier of large datasets, as a network modelling assistant, as a prioritization engine, as an analytical support system, it transforms scale into structure, and structure enables disciplined judgment. In intelligence work, speed matters, but so does restraint. AI accelerates detection, human oversight governs action. If you want to understand how those analytical outputs translate into operational intervention, that process is explored across the wider UK intelligence and counter-terror series on this channel.